Hey students, this is your maths teacher, 11th standard mathematics, continuation of first lesson. So here, first you have some definitions. This you have in your lower class also. The first one, constant, a quantity that remains unaltered throughout a mathematical process is called a constant. So no change in your process. Okay, unaltered is nothing but no change. So that is your constant. So your question is define constant. Okay, so this is your answer. It's clear. Like that, variable, a quantity that varies in the mathematical process is called a variable. Okay, it can change the values, that is called a variable, right? For example, y equal to mx plus c, your x and y are variables, m and c are constants. Okay, like that, the next one will be intervals. A subset I of R is said to be an interval. Okay, a subset I of R, you know what is R, real numbers, is said to be an interval if I contains at least two elements. What is the meaning of at least two elements? We need two number like 4 comma 5 2 comma 3, and a comma b belongs to I, and a is less than c less than b, then c is belongs to I. For example, interval, you know, in our time to reason, 10 to 10:15 you have break time, like that 12 to 12:30 you have break time, that is called interval, right? So in intervals we have two types. The first one open interval, second one closed interval. Okay, so in open interval we can read as open interval a comma b, that is nothing but a less than x less than b. And closed interval, this is read as closed interval, so a less than or equal to x less than or equal to b. So what is the difference between open interval and closed interval? In open interval we cannot take a and b, other than a and b we can have all the numbers in between these two numbers, and here it is includes your a and b. For example, 1 comma 4 means it starts from 1 2 3 4. At the same time here 1 comma 4 means it can take values 2 3 2 3 only. Okay, so that is the difference between open interval and closed interval. And after that you have some subdivisions of the intervals that you can refer your textbook. One side open, other side is closed, and both sides you can include, like that you have different numbers. Okay, different intervals. So the next one will be relations. In our day-to-day life, very often we come across questions like this: how is he related to you, right? Some probable answers are he is my father, he is my teacher, he is not related to me. So you can understand this type of questions, so that is called your relation. So in mathematics also we have relations. So in mathematics, what is relation? In which connects mathematical objects, you know. For example, a number m is related to a number n. We are relating two numbers. If m divides m divides n in natural number. Suppose it is integer, means anything by 0 is not defined. So we are particularly mentioning where your m and n belongs to system, number system. So that is your natural number. Do you understand? So that is one of the relation. Like that, a student x is related to a particular school, right? If x is a student of S, that is one of the relation. You are related to particular school, right? And the next one will be the relation between x and y is y equal to x square. So that is one of the equation. When you are taking x equal to 2, your y value will be 4. That is called a relation, right? So it is plays a very important role in our first lesson, but it is not easy like other exercise. So you have to read and two times, then only you can understand what is relations You have more definitions and difficult questions also you have. So first of all, how to define relation? Relation, the definition. Let A and B be any two non-empty sets. A relation R from A to B. This is read as R from A to B is defined as a subset of the Cartesian product of A and B. So first of all, you should know what is Cartesian product, right? I think you are all familiar in Cartesian product. So if you have any set, you can find out the Cartesian product. So relation is fully depends on your Cartesian product. So any set is given, you have to find first Cartesian product. Okay. Now if R is a relation from A to B and if x comma y is belongs to R, this is our element of relation. Then sometimes we write x related to y. This is read as x is related to y. So you should know the notations in your higher secondary. Like that, the next one will be x is not related to y. I strike out the R, so it is read as x is not related to y. So you can read the remaining things yourself. The next one will be some definitions of basic relations. Let S be any non-empty set and R be a relation on S. Then we have three definitions. The first one will be reflexive. R is said to be reflexive if A is related to A for all A belongs to S. The particular statement is true for one particular element, so that is called reflexive. Reflexive example, we can say 1 comma 1, 2 comma 2, 3 comma 3. That is called reflexive. The same number should appear in second place also. That is reflexive. It is clear. So you don't confuse with your statement. You have to think what is reflexive. 1 comma 1, 2 comma 2, 3 comma 3. Both elements are equal means that is called reflexive. You have to check your set whether you have the numbers or not. It is clear. That is called reflexive. The next one will be symmetric. You know the line of symmetry in English alphabets like H, right? So you have two lines of symmetry. Like that here, in relation, R is said to be symmetric if A is related to B implies B is related to A. 1 comma 2 one element. Then 2 comma 1 is symmetric. 1 comma 2 symmetric is 2 comma 1. So if you have elements 3 comma 4, you have to check the set contains 4 comma 3. That is called symmetric. We will see that in examples. Okay. And the next one will be transitive. R is said to be transitive. A is related to B and B is related to C. That implies A is related to C means it is transitive, right? So next one will be equivalence relation. Let S be any non-empty set and a relation on S is said to be equivalence relation if it is reflexive, symmetric and transitive. So equivalence means we need all the three relations: reflexive, symmetric, transitive. Otherwise it's not an equivalence relation. Okay, that's it. So the next video you can see. So in our mathematics we have more questions and more examples. Officially we will upload 1 or 2 videos. Other videos you can see from the YouTube channel. Thank you, students.